Hi, good morning, ladies and gentlemen. I would like to introduce the Water Quality Chair. I'm a co-chair of the UNESCO chair, WENDI, and this is the person who is also involving our development. So historically, we have actually in 2015, we have a very big UNESCO International Scientific Symposium organized here in Kyoto University, gathering almost 100 people from all over the world. And that scientific meeting was very, very successful, and that is one of the motivation for the establishment of the WENDI. And most of the resource has been provided by UNESCO IHP. The outcome is actually, it's all available in the OCW. So you can take all the presentation and discussion free of charge by clicking this, by Google this address from Kyoto University. You have all video and also all presentation. And one of the conclusion was to elaborate some of the state-of-art technology into the water quality management. So we focus on the use of the satellite remote sensing for the lake and the watershed monitoring, and that is the basis of the development of the global lakes and reservoir repository. So, about the water quality co-chair, this is a member of the co-chair of the water quality course. I am a co-chair of the whole program. And then these professors, including Professor Fuji, Professor Sadahiro Etau, Minoru Yoneda, and probably Yoshihisa Shimizu, will give provide the water quality related WENDI course. So those who are interested in joining the water quality issue will be attending those lectures provided by those professors. About the Global Lakes Reservoir Repository, GLR, we have currently 600 lakes and reservoirs already with the basic data. However, the major goal is how to apply the remote sensing data into those lakes. We have started from the Lake Beaver. This is one of the study which has been published and then launched in the Kyoto University. It is use of the Landsat 8 and to classify and quantifying the submerged aquatic vegetation which is dominated in the south basin of Lake Beaver. This is a classification result of the different species of submerged aquatic vegetation. And this is a field work. Actually, we will do for all of this week from tomorrow, starting from tomorrow. So starting from tomorrow, we have to go to Lake Beaver. I'm sorry, I have to skip the field visit because of this due. And it is very intensive work. We have to hire the diver and then cut all the timbers and then measure the chlorophyll concentration and then to trying to find the correlation between the Landsat data and the water quality. Of course, the Landsat is not the perfect one. We are also thinking for applying the different things. But the important thing is when you have a clear water lake like this and a dirty or turbid water lake, and turbid lake does not reflect a lot of, does not penetrate a lot of light. So we cannot distinguish the species below like 1 meter. But clear lake, you can see 20 meter. But we find in the clear lake also has a problem because of the very small signal just we have visited. And this is an example of the estimation of the chlorophyll concentration, mainly done by Dr. Sweater. And this is transparency, and this is a quantification of the biomass. And this reduces the cost of the human-based and the field monitoring of the lake. And this is also the biomass estimation and the attenuation coefficient. We are developing it's already in the sky, the GCOM-C. It's a JAXA satellite. I'm also the PI, and then we are getting the GCOM-C data in order to have a better classification. The GCOM-C almost provides every day global data, but it's a little bit coarse. But for the Courseware, for the larger water body, it is enough. Of course, it is not enough for the small water body. So the advantage of the new satellite can provide better resolution in terms of spectral band. The Landsat has only 4 bands between the visible ray and the near infrared ray, but the GCOM-C can provide 8 bands. And then we have to conduct this in the globally. And I want to show one of the examples. This is, I visited the United States 2 weeks ago and making spectral measurement. This is Lake Tahoe, just demonstrating I'm working for this purpose. Actually, this is just for the spectrometer. This is not enough for observation. You have to get more things. And then to try to develop the global lake database, it's already there, but for the final calibration has to be made by the many collaborating country and collaborating institute. And then this is one of the example, Lake Maninjau. And then this is the different work that we are also working for the river into the ocean with the University of Plymouth. And this is like water release from Japanese river into the ocean. And this is also the freshwater release into the ocean. And these kind of things we have made a presentation in the World Water Forum 8 in the Japanese booth. And hopefully in the Stockholm Water Symposium, there is a plan to make a short presentation in Stockholm. So thank you very much.